welcome to the second experiment under the speech part of the DLP course. Okay, so this will be week 2. So week 2 of speech. Okay, so I am going to be this is week 2 for the speech part of it. Okay, and I think already 4 have we done. So 5, this will be in the DLP itself, the 7th kind of experiment, right? 6th kind of experiment, right? Because 4 experiments were already done under text, one on language identification based on the speech signal we did, and today we are going to do another experiment, right? Another idea using speech signal, which will be very, very interesting, and that is called speaker diarization. Okay. So, if you know, and following the speech part is the vision part, right? So, Professor Kaushik will deal a lot with the images, the videos and so on. So, one of the important or really good applications is face recognition, right? So, ideally you want to take a picture of the entire classroom and identify the faces in the classroom, and automatically attendance can be taken, right? So there are these technologies that happen in vision, right? Similarly, in speech also you might be interested in identifying a speaker based on their voice, right? So the voice itself acts like a biometric, and this is a very, very useful biometric, simply because if you are doing telephone based banking, for example, right, obviously you will be entering your PIN number and so on, correct? But I would also like to use your voice to authenticate whether you are indeed, if I am claiming to be Umesh, my customer ID is so much, I enter the PIN number, in my mobile app, and let us say now telephone based banking, everything is based on voice, right? My voice itself should also act like an additional check whether I am indeed the person and not somebody has borrowed my PIN or done something with malified intentions and try to hack into my account, right? So I can use speech as an additional thing, and speech is a little less, if people are not comfortable giving fingerprints nowadays. Of course, we use on our mobile phone, right? But speech is a little more less intrusive kind of thing. But speaker recognition, speaker verification have many other defense kind of applications, right? So if I am going through a large amount of audio and I am looking for speech from a particular person, right? For example, certain terrorist kind of activities, I have some sample voices and I want to see if this particular person is speaking somewhere in the large amount of audio that I am collecting at the border, right? So therefore, if that person's voice comes, it should immediately be flagged, because we would like to see what is he saying, whom is he instructing, what is he planning to do, right? This could also be generally, if I want to find out, like, when did the Prime Minister speak on a particular topic, right? So I can also look over large volumes of audio and find out where all the Prime Minister spoke. And then there is another aspect called keyword spotting, where he has used specific terms, and then I can pick only those clips. Or if you are looking at my or this whole DLP lectures, right? Suppose they were available, of course you can go lecture by lecture by lecture, but suppose we were all interacting, right? Professor Mitesh, myself and Professor Kaushik, we are all talking, right? And 1 hour with you people, right, on this course itself. Now you might suddenly want to know when did Mitesh say what, when did Umesh say what, when did Kaushik say, what did he say? This is where we talk of like speaker diarization. So if you are in a meeting, right, so you have one big conversation going on, right? A meeting is basically multiple speakers in the room that are all speaking, and you pick up the audio from each one of them, right? So you have a big 1 hour of audio, and there are two or few things that you may want to do with this audio, right? First thing is you want to convert that audio to text, right? Why? Because so many wonderful things you can minute. For example, we are having a parliamentary meeting, right? There are so many members of the parliament, so many ministers who might be saying so many things, right? So the entire session I can convert it to text, right? So that it is minuted and actually documented what was said in the parliament during this particular meeting, right? Or if I am having a board meeting in a company or some executive meeting and I have lots of people talking, I would like that to convert that whole 1 hour of audio or 2 hours of audio or 4 hours of audio into text, right? So this is called automatic speech recognition, okay? Okay. So given the audio, you will get some kind of a text at the output, right? I am going, I keep saying this because for lack of, I'm just not thinking, so, some editable text is going to come. So this is also called a speech to text problem. So given the speech signal, I am converting it to text, okay? And this is very, very important in many applications, right? Once I convert it to text, I can use powerful ideas from NLP to do something with the text. I mean, if I identify that somebody is looking for account information, I might go to the database, fetch the account and play out. So there's also TTS, right? Play out, right? So you want the machine to talk back to the human, right? So this is the speech to text or the automatic speech recognition is where the machine is trying to convert what you're saying to text, and it's one step just before understanding. A machine is not that brilliant like a human brain that it can understand the nuances, but it will give a general idea about what to do. So basically, if I say I want to go to the bank, right, you as a human can actually distinguish the context in which somebody is saying. If you can see a river flowing and if I'm saying I want to go to the bank, then it's from the context you're sort of aware that I'm talking about the river bank. But if I'm standing in front of some building, big building, in front of an ATM or something, then you know that I'm talking about a financial institution, the bank which deals with money, right? So bank itself has two different meanings or ways depending on the context, and therefore understanding is one level higher, okay? But speech to text is an important part, right? Because once I get the text, I have pretty much at least converted to into text what you wanted to say, and then I can use some NLP ideas to build on it, right? So, and remember, speech is very, very important, right? So most people can't read and write. At least speech is very important in India, right? So if I want to communicate, everybody knows how to speak, right? I mean, you take even the remotest village, the person can speak some language, right? He can communicate, he can tell you what he wants to do, what his problems are, everything, right? And therefore, if you use speech and convert it to text, then we can use the power of LLMs, we can use so many things to do some wonderful things. And the other part is also, one important part of text is translation. So if I go to Kolkata, I'm let's say South Indian from Karnataka or Bangalore or Chennai or Kerala, I don't know Bengali, right? But when I go to Kolkata, obviously the auto driver, the taxi driver, they know only their local language, they know only Bengali, right? So how do I communicate to this Bengali person? So can I speak and say in my mother tongue, ನನಗೆ ಇಲ್ಲಿಂದ ಹೌರಾ ಬ್ರಿಡ್ಜ್ ಹೋಗಬೇಕು? That means in Kannada I am saying I want to go to Howrah Bridge, right? And if that get converted into Bengali, that makes the job of the other person very easy, right? So then the language barrier is reduced in itself and people can communicate with each other, right? So speech has very, very important role, especially in a country like India where reading, writing. If I want to book a ticket, right, I have to know how to log in, read, book, choose the ticket, the train, do X, Y, Z. But if I can do everything through voice, that's very, very powerful, right? So therefore, we will talk about this aspect of speech to text in the next experiment that we are doing, okay? But in this experiment, I was giving you this idea of speaker diarization, and let us take it in the context of a meeting, right? So let's say I am in a meeting, right? And let us say that, like as I said, there are three professors, Mitesh, Umesh and Kaushik, who are discussing different aspects of the DLP course, right? And therefore, if I have this entire meeting recorded, right, and I convert it into speech to text or ASR, right? Right? It's going to give me some kind of output like this. I mean, I'm writing it. This course is wonderful. Okay, you will benefit a lot. Okay. Okay, deep DL background is expected. I can, this conversation is going on, and some of it maybe you as a student asking questions to us also. So all this is getting recorded, right? But if I just write it in one big line, right, it's not readable. It's actually not at all clear, and it's very, very difficult to follow what happened in the entire meeting or the entire classroom interaction. On the other hand, if I said, Umesh said, welcome to this class, then student 1 said, thank you, okay, then Mitesh said, we expect you to know deep learning, etc. So this guy is very readable. Okay, there are two parts that are happening here. One is a speech to text, and the other is called speaker diarization. Okay, so speaker diarization is one part of voice biometrics, but it is not worried about security. Instead, it is trying to address who who spoke when. Okay, so this speech to text is what was said. That is the basic idea of speech to text. Given a speech signal, what is said in the speech signal? What is the text in the speech signal? Okay, that is the goal of speech to text. In speaker diarization, it is who spoke when. When did Umesh say what did from what time to what time in that video conversation, video meeting, did he speak? Did he speak from first minute to 7th minute, then from 13th minute to 16th minute, then from 23rd to 25th, and then he said haha, something. I mean, that's very, very difficult. So those are called disfluencies. So very short clips are much more difficult to do diarization. But yeah, I might have spoken from 23 minutes 47 seconds to 53 seconds. Okay, that's only a 5-second clip, but I need to pick that up, right? I might have just interrupted, no Mitesh, wait, something like that, or no student, wait, right? Something like that I might have just said, right? So I still want to record that, and I want to record it in such a nice fashion that it becomes readable. Oh, okay, Umesh said welcome to the class. In response, the student said thank you. Then Mitesh said we expect you to have deep learning background, etc., etc. Kaushik said I'm going to be doing the vision part of it, right? So you are going to get some kind of a nice output like this. And this is very, very helpful in two ways. One is the understanding part. The other, like as I said, that if I have a big conversation, I want to pick up, right, in the video, when did this guy speak, right? And I have to only worry about looking. So I am interested in only a speech course, right? And I have a huge recording, right, of tens of thousands of hours, but I don't know where Umesh spoke, and I know Umesh is a guy who deals with speech, right? So then if I can figure out where all Umesh spoke, then I can look at only that part of the videos and then learn what was said, right? So if the video, in our case, we are taking turns, right? So this is a simple case where I spoke only during my 4 weeks. I'm speaking only about my lecture, so it's not a problem. But when you have a conversation or in a meeting, right? So let's say this, we are always interested in what the CEO said or what the chief finance officer said. So I want to pick up all those clips in the last 10, 20 meetings, what all the CFO said, and from that, as a stock market analyst, I want to sense whether there is some problem with the company or not, right? I'm going to analyze, and I want to see every time how the CFO said what, when, how, etc., right? So therefore, this idea of diarization is picking up from big audio conversations a particular person's speech. Okay, so we are going to solve this problem in a very slightly roundabout way, we are going to use a technique which basically is going to use speech to text. So, I am going to first use speech to text, and then I am going to use basically a speaker verification or speaker identification model. Okay. So, first I am going to use speech to text, then I am going to use a speaker identification model, and I will come to that, and then I am going to do speaker diarization. Okay. So, speech to text is basically what was said. Okay. It does not care who said it, when he said, nothing of that sort. It is only going to worry about what was said. Okay. And second part is we are going to use speaker identification, and this I'll write it next page, so it's a little more clearer to you. So, first I am going to use a speech to text. Okay. Okay. In this particular case, we are going to use what is called a whisper model to do this. Okay. And this is from OpenAI. Okay. All of you know what OpenAI is. OpenAI is the company that actually built some of the most what is called really exciting thing. People have got excited about it. So, one of the first things that they built was this Whisper ASR model, and it's built on a huge amount of data, right. It's built on 680,000 hours of speech data. Okay. And it's one of the best English models that you can ever get. Whisper can handle some of the Indian languages, but the quality is not so good. But remember, in any one of these models, the training data determines the performance of this model, right. So, even this Whisper model has seen about 5 out of the 680,000 hours, about 540,000 hours of English itself. Okay. So, it is dominated, and that too by American English. Okay. The rest 120,000 is made up of lot of Chinese, Japanese, Spanish, German, the Western European languages, and very little of Hindi and Tamil, Telugu, and very little. I think it's not even like 10 hours of Kannada or something. Okay, in the 680,000 hours. So, obviously Kannada, it's not going to do a very good job. Okay, so we will restrict ourselves only to English. Okay, and Whisper is a very good model for English. Okay, now this is a speech to text. What is a speech to text? We will actually try to do a speech to text problem in our course the next week. But basically, the speech to text problem or ASR problem is basically given the speech signal, I am going to convert it to text. Okay. Whisper has been trained in a way that it also gives you the timestamps of the text. Okay. So, it is going to give you like 2 minutes 3 seconds to 2 minutes 8 seconds. This is a test. Okay. So, it is not telling you who spoke when, that part is not there, but it is going to say that in the audio clip from 2 minute 3 seconds to 2 minute 8 seconds, the the words this is a test was said. Okay. Then 2 minute 8 seconds to 2 minutes 17 seconds, therefore, the success depends on your input or something. Okay. So, this means that in the audio or speech clip from 2 minute 8 seconds to 2 minutes 17 seconds, the following words is said. Therefore, the success depends on your input. It is possible that this guy was spoken by one speaker and this guy was spoken by another speaker, or it could be both were said by the same speaker. Okay. So, this is not conveyed by Whisper. Okay. Whisper will not convey to you whether there was a change in speaker, who is the speaker, all this will not get conveyed. Okay. So, we are going to use Whisper, okay, to do this. I will explain how we are going to exploit it. Second, we are going to use a speaker identification model, or what's called a speaker embedding extractor. or speaker feature, the feature of a speaker, right? Speaker feature extractor. Okay. Again, this one we are going to take a very commonly used model. So there are some very nice software toolkits that have been developed by the academic community in speech, at least. Okay. So there are free software toolkits. Okay. So speech toolkits, these have been free, these are open source, and they are built by academic community. So for example, there was Kaldi, which was developed by Cambridge and Johns Hopkins. Okay. So Johns Hopkins University. Then there's ESPNet, which is also coming from Johns Hopkins. Okay. And now the professor has moved to CMU, so it comes from CMU. Then there's a SpeechBrain, which comes from, I think, the Mila lab. So if you know, there are three big people in deep learning ideas. One is Jeffrey Hinton, the other is Joshua Bengio, and the third is Jan LeCun. Actually, there's another very important person called Schmidhuber. He's also made a lot of contributions to deep learning. Okay, he's a German, but the Mila lab basically is from Joshua Bengio, and some of his colleagues or some of his lab faculty members have developed something called SpeechBrain. So we are going to use SpeechBrain toolkit, and in SpeechBrain toolkit they have already built a good speaker embedding extractor called E EART EDNN model. Okay. So if you recall, we had similar ideas already dealt with in the previous week. Okay. For example, I said you need to extract some useful information for the classification problem, right? For human to distinguish between a child, a woman and a man, I used height and weight measurement from the human, right? I would take the height measurement from the human and the weight measurement from the human, and then with the class labels, so that during inferencing, if you just give me a height and weight, I could identify whether it's a child or I mean, of course, there'll be errors, whether it's a child, man or a woman. Then we went the same three class problem from man, woman and child. I just converted it to a 3 language classification problem, whether it is English, Spanish or Romanian, right? Again, I need to extract some useful features, correct? And therefore, one of the useful ways that we did last time was using something called a wave-to-vec model that was created by Meta, and I passed that speech signal through this wave-to-vec extractor, and I got one vector out of it, right? And that is basically my representation for a man, for English. And similarly, I passed something and I said that's a representation for Spanish, and third was a representation for Romanian. But using these features, then I built a CNN based classifier to do it. Okay, but you could use simple ideas like we did for the vectors in heights and weights, and for speaker verification, that seems to be a that simple classifier, it seems, works reasonably well. Okay.